All right, welcome back. Oops. We are on day 2 of our ACT Prep Unit 4, which is Intermediate Algebra Topics. And we're talking about absolute value equations and inequalities today. So when you have absolute value equations and inequalities, it says when solving absolute value equations, equalities, and inequalities, you must consider two possibilities. For example, if the absolute value of x is 7, then x equals 7 or x equals negative 7. This goes against everything we've taught you. We've taught you that anytime you have absolute value, that just means your answer is positive. And for everything you've done up until probably algebra, that was true. Okay, but in algebra, what the absolute value actually means is the distance from 0. So if you're talking about the absolute value of 7, there's actually two answers. I can go 7 units this way, and that's the absolute value of 7, or I can travel 7 units this way, and that's still 7 steps. 7 steps. Both of these are 7 units away from 0, and that's what absolute value means, is distance from 0. So now that you're a little bit older, we're going to get a little bit more in depth into absolute value. Before, up until we considered integers or whatever, yeah, absolute value just really kind of meant positive. But now you're looking at what really absolute value means, and that's distance from 0, and there's always two directions you can go from 0. Okay, to solve absolute value equations and inequalities, you must solve for each case, and I don't do this. I kind of do it backwards. The way I do it is, if you're doing equations, meaning there's an equal sign, then all you do is drop, keep, and for your second equation, drop, change. And I'll explain what that means in a second. But for inequalities, meaning you have a less than, a greater than, a less than or equal, a greater than or equal, okay, one of these, then it's drop, keep, and drop, flip, change. Okay, so for equations, it's drop, keep, and drop, change. For inequalities, it's drop, keep, and drop, flip, change. What the heck are you talking about, Hammy? Well, for example, we have the absolute value of x minus 8 equals 5. Well, there's two conditions. This quantity can be 5 units from 0. Or this quantity can be 5 units to the left of 0. So what I mean by drop, keep is literally, I should do this different colors. You drop the bars, so I dropped the bars and wrote x minus 8. You drop the equal sign, and you keep the sign on the other side. So that's drop, keep. Then you have to drop, change. So to get the other one, I drop the x minus 8. I drop the equal sign, and I change the sign of 5. So that would be negative 5. And there's your two separate cases. 5 units to the right or 5 units to the left. And then you solve them both. In other words, you're going to get two answers. So if I add 8, I get x equals 13. Add 8, I get x equals 3. My two solutions are 13 and 3. And I'll show you the graph here in a second. Okay? And explain why there are two solutions. But there are two solutions, 13 and 3. Now, for an inequality, you're going to drop, keep, and then you're going to drop, flip, change. Okay, so drop, keep is going to be x plus 4, drop it, 7. You keep it, in other words, you just write it without the bars. The second one, you drop the bars, but you have to flip my inequality, so the less than turns into greater than, and positive 7, you change the sign to negative 7. Those are the difference in your two. Again, you got one extra thing for inequalities. You flip it. Flip the inequality for the second case. So in the first case, minus 4, I get x is less than 3. Minus 4, I get x is greater than negative 11. Now, when you have inequalities, okay, how do you write these two answers? Okay, because what this says is x is less than 3, but it also says x is greater than negative 11. Well, how can that possibly be? Well, and I promise you, okay, let's graph it. So if I graph x is less than 3, 3 is going to get an open circle and go left. Anything smaller than 3 works. If I graph the x is greater than negative 11, can't include it because there's no bar, but greater would be everything this way. So what this is saying is, where are my solutions? Well, your solutions are going to be where there's green and purple. And that's going to be in this section right here. And the way you say that is, okay, when will x be less than 3 and greater than negative 11? And that's what I was going to show you. And what I promise, 99% of the time anyway, is if the bars are alone, and you can't have anything else over here. So if there was something added outside or multiplied outside, you'd have to get rid of that first. But if the bars are alone and it's pointing at the bars, it's going to be an and statement, I promise. Okay? If the inequality is eating the bars, it's going to be an or statement. And then you can tell by the graph. So you don't really necessarily have to memorize this, but it should be a clue of what you expect to get. If the point is pointing at the bars, you should expect this union, or I'm sorry, this intersection, okay? These two overlap each other, which is an and statement. Now the way you write this is you say the set of all x such that, and I don't know if they'll use this fancy term, but for sure in the middle the way they write this, this is saying that your answers are between negative 11 and 3. So to say that, watch, you say my answers, x, are between negative 11 and 3. Well, if they're between, that means x is bigger than negative 11, but smaller than 3. So your arrows will, if you write it correctly, if you write little letter big, then I promise your arrows will always, always point left. And then if there was a bar to begin with, you put a bar here, but there wasn't, so you don't, and that's my solution. This is what an and statement looks like. Okay, you have to put the letter between the two ends of your answers. Okay, and that's what's going to happen every time you get the inequality pointing at the bars. Okay, what does this look like graphically? Let's take the same problem. Okay, to get absolute value, you go to hit your math key, which is right here, then arrow over to num, and absolute value is choice 1. So on y equals, I typed the absolute value of x minus 8, and on y2, again, you type this side on y1, this side on y2. I had to play with my window so that I could see the good picture, okay, because what you're expecting is, anytime you see absolute value bars, you're going to get a V somewhere. So this is going to be a V shape, this is going to be a horizontal line, and you can see that they intersect at 3, and I calculated this intersection point at 5. But again, you now have to figure out your oops, apparently I didn't figure that out. You have to figure out your inequality. Well, it wants to know when is the V equal to, oh, this one you don't have to, never mind, I'm sorry. When is the V equal to that line? Well, when you're doing equal to, it's just your intersection points and you're done. So there's your 3 and your 5. Okay, there is no shading because this is not an inequality. On 2, however, all right, I typed in the absolute value of x plus 4 for y1. I typed in 7 for y2. Had to play with my window a little bit. Got the good picture. And sure enough, there's my solutions, negative 11 and positive 3. But this one is an inequality. So I'm trying to figure out where is the v below 7. And that is from here to here, which means my solutions are between negative 11 and 3. Okay, so like I said, calculator, yeah, it's interesting, kind of neat to make it do your work for you. But again, by the time, it's just as easy to do it by hand. All right, so you try this one, hit pause, come back when you're ready. And hopefully you got 7. All right, so I have to, it says, which of the following is the largest number that will make the inequality true? Well, I got to figure out the solutions before I can figure out the biggest number. So I'm going to drop, keep, and then I'm going to drop, change colors, flip, change the sign. Okay, and then there's your two cases. So we solve each one of them. This one I'm going to, sorry, I want to change color there. I'm going to add 8. I get 2x is less than or equal to 14. Divide by 2, and x is less than or equal to 7. Got to solve, so if I graph that, 7 is going to get a closed circle, and I'm going to go left. I'm expecting an AND statement because it's pointing at the bars, so I'm expecting overlapping here. If I do the second one, I'm going to add 8. That's going to give me 2x is greater than or equal to 2. Divide by 2, I get x is greater than or equal to 1. So 1 can be included and everything bigger. Okay, so this is going to be an AND statement. We'll see where the green and the red overlap. That's where my solutions are. My x's are between 1 and 7. And they're included, so I need my bars. Okay, so that would be my solution. And then it says, which of the following is the largest number that will make it true? The largest number that I can't go past is 7. Okay, if it would have asked you for the smallest number that will make it true, that would have been 1. And again, I did it on the calculator, but like I said, by the time you type them in, get a window that works, find your intersection points, and then you still have to decide when is the V below the line, which would be between your intersection points, 1 and 7. All right, so let's just practice. All right, so on this one, let me draw some lines here. Probably shouldn't have tried to put so many problems on the same page, but all right. So for the first one, I'm going to drop the bars, drop the inequality, drop the other side. The second one, I'm going to, sorry, I'm trying to give myself enough room. The second one, I'm going to do drop the bars, flip the inequality, and change the sign on the other side. All right, so we solve them both. I'm going to add 4. I get 3x is less than 18. Divide by 3, x is less than 6. So if I draw that, 6 is going to get an open circle and go left. And again, I'm expecting an AND statement because it's pointing at the bars. So I'm expecting overlapping to happen on the second one. On the second one, I'm going to add 4. 3x is greater than negative 10. Divide by 3, x is greater than negative 10/3. So negative 10/3 is going to get an open circle, and greater means everything to the right. And where they overlap on an AND statement is your solution. So my solutions are between, but not include, negative 10/3 and 6. Okay? All right, 2, again, I'm expecting an AND statement because it's pointing at the bars. So I'm going to drop the bars, drop the inequality, keep the sign the same. And for my second one, I'm going to drop the bars, flip the inequality, and change the sign on the other side. So now when I graph or solve both of these, I'm going to add 6, and I get x is less than or equal to 15. On my number line, I get to include 15 and go left. On the second case, I'm going to add 6, and I get x is greater than or equal to negative 3. And I can include that and go right. So my final solution is where they overlap, which is everything between and including negative 3 and 15. That'd be your solution. Okay? An equal sign is an or statement. You just have x equals this or x equals that. In other words, you have two answers. So this one is drop, keep, and drop, change. So that 11 becomes negative 11. All right, then we solve them both. Minus 3, x equals 8. Minus 3, x equals negative 14. And this is included, and this is included, and that's it. So my solution is 8 and negative 14. Do not put round parentheses. That will look like you're answering as an ordered pair, and our answer is not an ordered pair. It's two distinct solutions. All right, on 4, now this one is going to be an OR. See the difference? Now it's not pointing at the bars, it's eating the bars. So let me show you what happens on something like that. All right, the process is the same. Drop the bars, drop the inequality, drop the other side, or keep the sign the same on the other side. The second one is going to be 5x, drop the bars, but then I'm going to flip my inequality and change the sign on the other side. So the top one to solve, I'm going to add 12, 5x is greater than or equal to 25, divide by 5, and x is greater than or equal to 5. So if I graph that, 5 would get a closed circle and everything to the right, everything bigger. Okay, on the second one, I'm going to add 12, I get 5x is less than or equal to negative 1. Divide by 5, I get x is less than or equal to negative 1/5. That's down here somewhere. I can include it, and everything's smaller. So do you see how now the graphs do not overlap? And this is an OR statement. And what it says is, my answers can be anything less than or equal to negative 1/5, or my answers can be anything greater than or equal to 5. Okay, so when it's eating the bars, when the inequality is, the open part is facing, I call it eating. You think of that like as a little Pac-Man with teeth. If it's going to eat the inequality bars, then you're going to get something that looks like this, an OR statement. When it's pointing at the bars, then you're going to get something like this, which is between the solutions. Okay? All right, so let's try some more. Draw some lines. And I shouldn't have tried to squish so many problems on the same page. All right, so on the first one, we're going to drop the bars, drop the inequality, keep the sign the same. Second one, we're going to drop the bars. We're going to flip the inequality and change the sign on the other side. Those are my two cases. So in my first case, I'm going to minus 8. That gives me 2x greater than 4. Then I'm going to divide by 2, and I get x is greater than 2. So I don't get to include it, but everything greater I can. Again, I'm expecting an OR statement, so I'm expecting this to happen. All right, solving the second one, minus 8, 2x is less than negative 20. Divide by 2, and x is less than negative 10. So negative 10 is not included, but everything that's smaller is. And what happened is what I thought would happen. The bars are going to go out because this is an OR statement. So my solution is x, my answers, x is everything smaller than negative 10, or x can be anything greater than 2. Okay, 6, this is going to be an OR where there's just simply going to be two answers because it's an equal sign. So I drop the bars, drop the equals, keep the sign the same. Drop the bars, drop the equals, and change the sign on the other side. Okay, and then I'm going to solve. So I'm going to add 3, 3x equals 15. Divide by 3, and x equals 5. Okay, on this one, add 3, I get 3x equals negative 9. Divide by 3, and x equals negative 3. And those are my two solutions. Okay, It's eating the bars, so again, I'm going to expect an OR statement, which means the solutions are going to do this. Drop the bars, drop the inequality, keep the sign the same, drop the bars, flip the inequality, and change the sign on the other side. And then we solve. So minus 5, 6x is greater than 4. Divide by 6, divide by 6, x is greater than 4/6, which reduces down to 2/3. So on my number line, 2/3 is going to get an open circle and everything bigger. On the second one, I'm going to minus 5, 6x is less than negative 14. Divide by 6, divide by 6, x is less than negative 14/6. Again, if I reduce, that's going to be x is less than negative 7/3. So negative 7/3 is down here somewhere. Can't include it, but everything's smaller. So my solution is all x's less than negative 7/3, or x can be anything greater than 2/3. Okay, on 8, eating the bars, I'm going to expect an OR statement again, which means I'm expecting my graphs to point away from each other. Drop the bars, drop the inequality, keep the sign, drop the bars, flip the inequality, and change the sign on the other side. Solving on both. I'm going to add 5, I get x is greater than or equal to 7. So 7 gets a closed circle and anything bigger. To solve this one, add 5, I get x is greater than or equal to 3. I did not flip my inequality. Schmo, Tamsin, sorry. I should have caught me on that. You probably did. Sorry, my bad. I forgot to flip it. So I've got, dang it, x is less than or equal to 3. So close circle and that way, which says x can be anything smaller than or equal to 3, or x can be anything greater than or equal to 7. Okay? All right, some more. Fun. All right, I'm expecting an AND statement now, so I'm expecting the things to do this and overlap because it's pointing at the bars. And there are weird times where it doesn't, but most of the time that's what's going to happen. So drop, keep, drop, flip, change. Make sure I flipped it this time. All right, then we're going to solve each of them. So I'm going to add 1. I get 3x is less than 6. Divide by 3, x is less than 2. Open circle, go to the left. Okay, solve the second case. Add 1. I get 3x is greater than negative 4. Divide by 3, I get x is greater than negative 4/3. So negative 4/3 is down here somewhere. Can't include it, but go to the right. And my solution then is where they overlap, which is between negative 4/3 and 2. And I promise, if you always go little letter big, your arrows will point left. No bar in the problem, no bar in my answer. Okay, 10. This time, again, I'm expecting an AND because it's pointing at the bars. So drop the bars, drop the inequality, keep the sign. Drop the bars, flip the inequality, and change the sign. And then solve them both. So I'm going to minus 4. 2x is less than or equal to 2. Divide by 2, x is less than or equal to 1. So I can include 1 and go left. Solving the second case, I'm going to have minus 4. 2x is greater than or equal to negative 10. Divide by 2, x has to be greater than or equal to negative 5. Close circle to the right. And this did indeed come out an and my solution is where they overlap, which is all the x's between negative 5 and 1, or included. If your problem has a bar, your answer has a bar. Okay, 11, I'm expecting another and statement because it's pointing at the bars. So drop the bars, drop the inequality, keep the sign, drop the bars, flip the inequality, and change the sign on the other side. Okay, then we're going to solve them both. So the top one, I'm going to add 3. I get x is less than 4. Dang it. So on my number line, I have 4, open circle, and to the left. Solving the second case, I'm going to add 3. I get x is greater than 2. 2 is below 4. Not included is an open circle. Bigger is to the right. And my solution is where they overlap, which is all the x's between 2 and 4. No bar in the problem, no bar in the answer. Okay, 12 is going to be an or statement because it's equal. So we're just going to end up with 2 solutions. Dang it. So drop the bars, drop the equal, keep the sign. Drop the bars, keep the equal, change the sign, solve each case. So minus 7, 2x equals 2. Divide by 2, x equals 1. Solving the second case, minus 7, 2x equals negative 16. Divide by 2, and x equals negative 8. So my 2 solutions are 1 and negative 8. Okay? Man, I guess I wanted you to practice these a lot. Alright, so this one I'm expecting, it's eating the bars, so I'm expecting an or. So drop the bars, drop the inequality, keep the sign, drop the bars, flip the inequality, and change the sign on the other side. Alright, then we're going to solve each case. To solve the first case, I'm going to add 3, 7x is greater than or equal to 10. Divide by 7, and x is greater than or equal to 10 sevenths. So if I draw that, a little lower, I have a 10 sevenths, positive, closed circle, and everything bigger. Solving the second one, I'm going to add 3. I get 7x is less than or equal to negative 4. Divide by 7, and x is less than or equal to negative 4 sevenths. That's down here somewhere. Or equal is include. Less is that way. This is an or statement, which says that x can be anything smaller than or equal to negative 4 sevenths, or x can be anything greater than or equal to 10 sevenths. Okay? Alright, on this one I'm expecting an and because it's pointing at the bars. So I'm going to drop the bars, drop the inequality, keep the sign, drop the bars, flip the inequality, and change the sign. Alright, so if I solve them both, minus 4, 5x is less than or equal to 0. Divide by 5, x is less than or equal to 0. And you can get 0 for an answer. So I can include it and go left. Solving the second case, I'm going to minus 4, 5x is greater than or equal to negative 8. Divide by 5, and x is greater than or equal to negative 8 fifths. So I write negative 8 fifths here, closed circle to the right. And just like I thought, they overlapped. My solution is where they overlap, which is here. So my x's are between -8/5 and 0. That would be my solution. Okay, eating the bars, so I'm expecting an or. Drop the bars, drop the inequality, keep the sign the same. Drop the bars, flip your inequality, and change the sign on the other side. Solve each case. I'm going to add 9. I get 4x greater than 12. Divide by 4, x is greater than 3. I graph that. 3 gets an open circle and everything to the right. Solving the second case, I'm going to add 9. I get 4x is less than 6. Divide by 4, x is less than 6/4, which reduces down to 3/2, which is like 1.5, so it's smaller than 3. Less than, so open circle, and less than would be this way. And I did get an or like I thought, which says my x can be anything smaller than 3/2, or x can be anything greater than 3. But anything in between will not work. It will make a false statement. All right, 16, this is going to be an or statement with just two solutions because we have an equal sign. So I'm going to drop, keep, and drop, change the sign. So -4. All right, solve each case. I'm going to -3, I get 3x equals 1. Divide by 3, and x equals 1/3. Solve in the bottom, -3, 3x equals -7. Divide by 3, and x equals -7/3. All right, 4 more. This is it. Then you can practice. All right, it's pointing at the bars, so I am expecting an overlap. So drop the bars, drop the inequality, keep the sign the same. Drop the bars, flip the inequality, and change the sign on the other side. Solve each case. I'm going to add 5. I get 8x is less than or equal to 14. Divide by 8, and x is less than or equal to 14/8, which would reduce down to 7/4. So on a number line, 7/4 would get a closed circle and everything smaller. Solving the second case, add 5, 8x is greater than or equal to -4. Divide by 8, x is greater than or equal to -1/2. So -1/2 is here somewhere, closed circles included, to the right is bigger. They overlap whenever x is less than or equal to, greater than or equal to -1/2, or, no, this is an and statement, schmo. My answers are between and include -1/2 and 7/4. Okay, be careful. See, I'm getting sleepy because we've done like 100 of these already. Okay, 17, I'm exaggerating, but still. All right, you get sleepy and lazy, and I just almost tried to call this an or statement instead of an and statement. All right, this one, again, is going to be an and statement because it's pointing at the bars. So drop, keep the sign, drop the bars, flip the inequality, and change the sign on the other side. Solve each case. On this one, I'm going to -3, that gives me 2x is less than 9, 10, 11, 12, 9. Okay, then I'm going to divide by 2, and x is less than 9/2 or 4.5, however you want to say it. 9/2 is positive, it's going to get an open circle and everything smaller. Solving the second case, I'm going to -3, I get 2x is greater than -15. divide by 2, divide by 2, and you get x is greater than negative 15 halves, which is down here somewhere. Open circle and everything to the right. And they overlap here, which is everything between negative 15 halves and 9 halves. Done. Okay, on this one, I'm expecting an OR statement because it's eating the bars. So drop the bars, drop the inequality, keep the sign. Drop the bars, flip the inequality, and change the sign on the other side. Solve each case. So on the top one, I'm going to add 5. I get 5x is greater than or equal to 12. Divide by 5, and I get x is greater than or equal to 12/5, positive, and it's or equal to. So we get a closed circle, and everything bigger would be to the right. Solving the second case, I'm going to add 5. I get 5x is less than or equal to negative 2. Divide by 5, I get x is less than or equal to negative 2/5. That's down here, closed circle, smaller means to the left, which says my answers are here and here, which says any x can be anything less than or equal to negative 2/5, or x can be anything greater than or equal to 12/5. Okay? Last one before you practice. This one I'm expecting an OR again because it's eating the bars. So drop the bars, drop the inequality, keep the sign the same. Drop the bars, flip the inequality, and change the sign on the other side. Solve each case. -1, x is greater than 13. Open circle to the right. -1, x is less than negative 15. That's all the way down here. Not included. Smaller would be left. So this is an OR statement, and my solutions are x can be anything smaller than negative 15, or x can be anything greater than 13. Okay? Alright, you try one, hit pause, come back when you're ready. And hopefully you got D. Alright, it says 16 and negative 10 are the solutions to which one of the following equations? Well, if you just start with the first one, I'm going to have x minus 2 equals 14 and x minus 2 equals negative 14. Add 2, you get x equals 16. That's good. Add 2, you get x equals negative 12. That's bad. So A is out. If I check B, I have x minus 2 equals 8 and x minus 2 equals negative 8. Add 2, x equals positive 10. We want negative 10, so that's out. Try the third one. I got x plus 2 equals 12 and x plus 2 equals negative 12. Minus 2, x equals 10. Again, I needed a negative 10, not a positive 10, so C's out. Choose D, and I have x minus 3 equals 13 and x minus 3 equals negative 13. Add 3, x equals 16. Add 3, x equals negative 10. Those are the solutions that I wanted. Okay? Okay, try this one. Hit pause. Come back when you're ready. Hopefully you got 2. All right, which of the following choices makes the inequality false? Well, I need to know what the solutions are. So drop the bars, drop the inequality, keep the sign, drop the bars, flip the inequality, and change the sign on the other side. Then solve each case. So I'm going to add 9. 2x is less than 14. Sorry, my 9s look like 7s. Divide by 2, x is less than 7. So if I graph that, open circle to the left. Okay, then I solve this one, add 5, add 9, I get 2x greater than 4, divide by 2, and x is greater than 2. So here's 2, but not included to the right. And they want to know which one makes it false. Well, if it falls in between here, it's true. If it's 2, 7, or bigger than 7, or smaller than 2, it's false. 3 is between, 4 is between, 5 is between, 6 is between. 2 is one of my, it's not a solution because it's not actually included because there's no or equal to. Okay, do this one, hit pause, come back when you're ready. And hopefully you guys see. I am expecting an or statement because it's eating the bars. So drop the bars, drop the inequality, keep the sign. Drop the bars, flip the inequality, change the sign. Solve each case. I'm going to add 5, add 5. I get 7x greater than or equal to 14. Divide by 7. I get x is greater than or equal to 2. So close circle on 2 and everything to the right. Solve the other one, second case. I'm going to add 5, add 5. I get 7x is less than or equal to negative 4. Divide by 7, and I get x is less than or equal to negative 4/7. Close circle in this way. My solutions are here and here, which says x is less than or equal to negative 4/7, or x is greater than or equal to 2. Again, you can do it on the calculator, but like I said, I think it's more work on the calculator than just do it by hand. Alright, try this one, hit pause, come back when you're ready. And hopefully you got F. It says x equals 6 is the complete solution set to which of the following equations? Okay, well on this one, there's only one answer. When you have absolute value, you're going to get 2, so all of those are out. And if I solved this, 2x equals 12, divide by 2, x equals 6. Yeah, that's the solution set. Okay, this one, if you solved it, divide by negative, you get x equals negative 6, which is not what they wanted. And last one, try this one, hit pause, come back when you're ready. And you should get D. All right, we want the product of the solutions, which means we need the solutions and then multiply them together. So drop the bars, drop the equal, keep the sign, drop the bars, drop the equal, change the sign, and solve each case. Add 3, 2x equals 18, divide by 2, x equals 9. Add 3, 2x equals negative 12, divide by 2, x equals negative 6. And then they want me to multiply 9 times negative 6, which is negative 54. Alright, so we are finished with day 2. I will see you next time for day 3.